students. Today we will learn very interesting concept of the group theory. When you enters to the PG classes in inorganic paper, there is the concept of group theory. What is the group theory? It is the advanced theory based on the mathematics for the molecules, which is applied to study the bond dipole moments, the bond interactions in the solvent phase, in the gaseous phase of the molecules, and to study the quantum and spectroscopic transition properties of the molecules. Because molecules are classified into groups, they are formulated inside the groups because according to their symmetry, molecular symmetry, elements and operations, the molecules are grouped into the certain groups. So that groups decides the characteristics of the molecules for the bond vibrations, bond rotations, or the transitions of the bonds in the molecules which takes place with interaction of the light. So let's study what is that concept. Look here, I am holding in the hand the model of the water. The water molecule has the sp3 hybridization, and these are the two lone pairs yellow colored. Water oxygen is at the center and it is the bent molecule. It is V-shaped molecule, or it has the distorted tetrahedral geometry with the bond angle 104 degree. So here water at the center oxygen, carrying center oxygen with the lone pairs, free lone pairs of the electrons, and these are the side two hydrogens. Here in this model I am holding in hand the black atom represents H1 one hydrogen, and white atom of the H2, that is second hydrogen. So water has the point group C2V. Why C2V? Because water has the elements of the symmetry elements, twofold axis of rotation like this. It passes through the oxygen. Water can be rotated two folds, two times in the 360 degree, that is 180 degree per rotation. So in this way water has a C2 twofold axis of symmetry. Water consists of the vertical plane of symmetry. When it is passes through lone pairs on the oxygen, it divides the two parts equal into hydrogen. So water has the vertical plane of symmetry sigma V. Another vertical plane of the symmetry passes through the hydrogens, it divides the two lone pairs at two sides. So water has another vertical plane of symmetry, that is sigma dash V. So here it is represented like this. Water has two vertical plane of symmetry and one C2 axis. So that is the C2 element of symmetry for the rotation of water, and for plane of symmetry reflection of the hydrogens. So in this way water has a C2V, one sigma V, another sigma dash V, C2V point group. So here the elements of symmetry under the water represented in the matrix forms like E, identity of the water means same self hybridization, C2 twofold axis of symmetry, vertical plane of symmetry sigma V xz, and sigma dash V sigma yz plane of symmetry, two plane of symmetry, one twofold axis of symmetry, and identity. If we represent these in the matrix forms, diagonally we get the same elements of symmetry, that is E, C2 here, sigma V here, another sigma dash here, reverse. So in this way water has character table. So in this character table the values becomes 1 1 1 1 for identity, 1 minus 1 1 minus 1 for C2 because the hydrogen changes the positions, and for sigma V it becomes 1 minus 1 minus 1 1 because in the sigma V reflections are there, and reverse value for their sigma dash V, that is 1 1 minus 1 minus 1. So in this way the atom of the hydrogen atom in the water changes the positions in the rotations and reflections for the C2 axis and plane of symmetry. So in this way character table of the water can be explained, and on the basis of these symmetry elements in the character table Mulliken symbols can be formulated. Water has four Mulliken symbols, and four modes of transition are observed for the water in the spectroscopy. For the UV visible or FTR interactions in the water. So water shows symmetric, asymmetric stretching, bending and twisting modes of the rotations, vibrations. So in this way the modes of transition, spectroscopic interactions, can be correlated with the character table. So that is the main application of group theory. Thank you.